I'd like to show you just quickly how I would use a zonal tool to calculate areas for classified land cover in Cook County. And this, I suggested this to a number of people on your final projects, that if you have a polygon shapefile for an area that you've classified, you can get very precise calculations of the area from the zonal tools in the toolbox. Okay, so here you can see I have this classified classification of land cover classification of Cook County. You can see I have 14 classes here, and I have a detailed Cook County boundary, as you can see. And I'm going to use a zonal tool, and the one I'm going to suggest that you use, this is in the Spatial Analyst tools, and it's the tool set in the zonal tools. You can see here are the zonal tools, and it's the tool called tabulate area. And so I'm going to take the tabulate area tool, and I'm going to input the zone data, and that's my Cook County detailed boundary. And the zone field, this is any field that is unique for each feature. Because there's only one feature, I probably could use any of the fields. I'm going to use FID, and that's the field, the first column in the attribute table that usually starts from 0 and goes up to the number of features in the table, and that is that is an attribute. An integer attribute. And so I'm inputting the raster or feature data, and this is my ISO cluster. This was an unsupervised classification, and you can see the class field that I have. There's only one field there, and that's the value, and that's one of these 14 values that's recorded for each of the pixels. And so if you look here, it's going to go into my default geodatabase. This tabulation is as a table, and then the processing cell size is 30. Now if I change that to 1, it would give me a pixel count, but because I'm going to leave it at 30, that's the size of the pixel, 30 meters, it's going to give me a measurement for each land cover classification in square meters, and so that'll be easily converted into square kilometers. So I'm all set with this. I'm going to go ahead and run it. You can see it's running, and there it is. It's done that quickly. And when I take a look at this table, I'll close that. When I take a look at this table, you'll see, let me bring it over. You'll see that this table has a list of values. Here's value 3, value 4, and you can see these values here are actually square meters. And so, for instance, in value 6, which you'll see in the table here, is this kind of urban land cover category. In value 6, I have 904,544,100 square meters. That's 904 square kilometers, because there's 1,000,000 square meters in each square kilometer. Kilometer is 1,000 foot long, so 1,000 squared is 1,000,000. There's 1,000,000 square meters in 1 square kilometer. And so this particular category, this particular land cover category, has 904 square kilometers in that particular category, 904.5 square kilometers. So you can produce very precise estimates of areas for analyses that you've done where you have a classified raster image. And again, this also works for change analysis as well. So try to use these tools if you can. This really strengthens your paper when you're doing it. And if you have questions about this, we can take a look at your particular problems in class.